We'll go ahead and begin section 1.3 in this video. It's called rates of change, okay? And the definition there to start, it says the average rate of change of a function f from a f of a to b f of b is f of b minus f of a divided by b minus a. Okay. So let's take a look at some examples of that. The average price of a gallon of gas in 2020 was $2.17. In 2024, it was $3.44. Find the average rate of change between 2020 and 2024. Okay, so, well, I have 2 points on a graph there. X is the year and Y is the price of a gallon of gas. So in 2020, it was $2.17, and in 2024, it was $3.44. Okay, and I'm going to use the formula for the average rate of change. So f of b is f of 2024 minus f of a is 2020 divided by b minus a, 2024 divided by, or 2024 minus 2020. 2024 minus 2020, that's 4, okay? F of 2024 is $3.44, right? Because they said in 2024 it was $3.44 for the price of a gallon of gas on average. And then in 2020, it was $2.17. So if I take 3.44 minus 2.17, I'm getting 1.27, okay? And then when I divide that by 4, we end up getting 0.3175. Okay, that's the average rate of change. That's also a dollar amount. Okay, so the price increased on average by about 32 cents. So, you know, if I were to round to the nearest hundredths place there, it'll be about 32 cents per year. Okay, let's try another example. Now, by the way, when I use this formula, the average rate of change can be a positive or a negative number. So like in this problem, it was a positive number. Okay, let's take a look at this example next. So in let f of x be equal to 50 minus 0.15 x squared represent the outside temperature in degrees Fahrenheit in December at x p.m., where x is a number between 6 and 12. Find the average rate of change from 6 to 9 p.m. Okay, so f of b is 9, a is 6, so f of 9 minus f of 6 divided by 9 minus 6 is what I get using this formula here. Okay, f of 9 is 50 minus 0.15 times 9 squared. Okay, and let's see, I'm getting 37.85 with that. Okay, and then f of 6, so if I plug in 6 there, I have 50 minus 0.15 times 6 squared is 44.6 is what I'm getting, okay? Divided by 9 minus 6 is 3. So then 37.85 minus 46 or 44.6 is negative 6.75. And then when I divide that by 3, I'm getting negative 2.25. Okay, And that's a temperature value. The temperature is in degrees Fahrenheit. So in other words, the outside temperature changed in this 3-hour time span from 6 p.m. to 9 p.m. by about 2.25 degrees Fahrenheit per hour. Okay, now that's a negative. So what that means is that the temperature decreased on average by 2.25 degrees Fahrenheit per hour on this particular day. Okay. Now, in this next example, we want to find the average rate of change of f of x equals 2x squared plus 3 on the interval x to x plus h. Okay, so I'm going to apply the formula for average rate of change, that guy there. And b is x plus h, a is x, so I got f of x plus h minus f of x divided by x plus h minus x. X minus x is 0, right? So I get h all alone in the denominator. Okay, now this formula, f of x plus h minus f of x all over h, that's an important formula that we're going to see a little later on. That's called the difference quotient. Okay, and that's another section. Okay, but the difference quotient is the average rate of change. Okay, so that's why they also kind of preview this formula coming up in this section. So f of x plus h means that wherever I see an x and f, there's only one x showing, I need to replace that with x plus h. So I got 2 times x plus h squared plus 3. Minus f of x is 2x squared plus 3. And I'm subtracting the whole thing, so I want to make sure that there's parentheses around that. I'll need to distribute the negative sign into the terms on the next line. Okay, and this is all over h. So then on the next line, I've got x plus h times x plus h. That would be x squared plus 2xh plus h squared. And I'm multiplying that by 2. So I get 2x squared plus 2xh times 2 is plus 4xh plus h squared times 2 is plus 2h squared. Plus 3 minus 2x squared minus 3 all over h. Okay, and I'm going to have some things canceling. So there's 2x squared minus 2x squared, those are gone. And then 3 minus 3, those are gone. And that leaves me with 4xh plus 2h squared up top. And then I'm dividing this by h. H is in common to these two terms up top. So let's go ahead and factor that out. And then we'll cancel it with the h that we see in the denominator. So when I bring out h up top, I have 4x plus 2h left over. I'm going to cancel those h's with each other, and I'm left with 4x plus 2h. Okay? Now, again, we'll do some more with what's called the difference quotient in a later section. So all they want you to do here is just to be able to compute the average rate of change, which is the difference quotient. So all you're doing is using this formula. Okay? And we'll talk about the meaning of this in another section there. Okay. So then the next thing is a definition. It says, let f be a function on an open interval, so parentheses at both ends, and scan the graph of f from left to right. If f is rising from x equals a to x equals b, then f is increasing on the interval a to b. And if f is falling from x equals a to x equals b, then f is decreasing on the interval a to b. All right, so let's take a look at some examples of that. So suppose I have a function here, and I want us to describe the open intervals where we're going to be increasing or decreasing. By the way, any questions about increasing and decreasing, you're always going to have an open interval. So parentheses everywhere on that stuff. Okay? So, yeah, well, here's the graph of f of x. So, like if x is 0, y would be 0. So 0, 0 is on the graph. If x is 1, 1 cubed is 1. Minus 3 is negative 2. So there's 1, negative 2 on the graph. If x is negative 1, negative 1 cubed is negative 1. Negative 1 times negative 1 times negative 1, that's negative 1. Plus 3 is 2. Okay, so there's negative 1, 2 on the graph. If I let x be 2, 2 cubed, 2 times 2 times 2, that's 8. Minus 6 is 2. Okay, so there'd be 2, 2 on the graph. And then if I let x be negative 2, negative 2 cubed, negative 2 times negative 2 times negative 2, that'd be negative 8. Plus 6 is negative 2. Okay, so there's the point negative 2, negative 2 on the graph. Okay, and I'm going to draw the curve now. So what this curve is doing is we're starting off in quadrant 3. We're heading upward. We're going to take a nice smooth turn at the point 1, 2. And then we'll head down. We'll cross through the origin. We'll take a nice smooth turn there at 1, negative 2. And then we'll head upward and outward into quadrant 1. So something like this would be a quick rough sketch of that graph. Now, I would like us to know where are we increasing or where are we decreasing on the graph? Okay, where are we rising and where are we falling as we scan the graph from left to right? You're always going to scan the graph from left to right. Well, if I'm scanning from left to right, let's see, I'm going to be rising until I get to 1. Okay, because at negative 1, at negative 1, 2, that's where I take a turn. Okay, and so I'm going to be increasing everywhere that would be to the left of negative 1. That should be a negative 1, sorry. And then, let's see, where else are we rising on the graph? Is going to be anywhere that's bigger than 1. Okay, so if I scan the graph from left to right, anywhere that's bigger than 1, I'll also be rising on the graph. So from 1 to infinity. Okay, you're going to be increasing on the graph everywhere that's less than negative 1 and everywhere that's bigger than 1. You're rising on the graph. Okay, so that's where you're increasing. And now where am I decreasing means where am I falling on the graph as I scan the graph from left to right? Well, here's, it looks like anywhere that's between negative 1 and 1, the curve is going to be falling on the graph. Okay, so you're going to be decreasing on the interval negative 1 to 1. Okay, now here's a note. Whenever we say where we're increasing or decreasing, it is all about x. It is all about x. I don't care how high the graph goes or how low the graph goes. It's all about x. Okay? So I'm stating this, my answer, in terms of the x values. Okay? I don't care that 1, negative 2 is on the graph. Right? It could be 1, negative 43. It doesn't matter. Okay? I'm still taking a turn at 1. Okay, so that'd be that problem there. Okay, and but by the way, so I'm using open intervals because I'm taking a turn at negative 1 and a turn at 1. So I'm going to be changing from increasing to decreasing at negative 1, and then be changing from decreasing to increasing at 1. I never want to include those values there. And again, you're always going to have open intervals for any questions related to increasing and decreasing functions. Okay. let's take a look at this one next. So suppose that I have a graph of the function p of t. So here's the t-axis, and here's the p of t axis, or the y-axis, same thing. And now I don't have a formula representing this curve, right? I just drew a curve, and now there's some key points on the graph, though. Okay, and again, the question is, where are we increasing, where are we decreasing? So where are we rising and where are we falling? Okay, well, initially, it looks like we're going to be falling as we scan the graph from left to right. Okay, and we're falling until I get to 1. So I'll say that we're decreasing everywhere that's to the left of 1. That'd be negative infinity to 1. And then where else are we going to be falling on the graph? Looks like right here. So from 3 to 4, you know, I'm falling there, and then I'm going to be rising after 4. Okay, so from 3 to 4, I will also be decreasing. Okay, now where are we increasing on the graph means where are we rising on the graph when we scan the graph from left to right. Well, it looks like anywhere that's between 1 and 3, I'm going to be rising on the graph. Okay, so be increasing on the interval 1 to 3, and then where else are we going to be rising? Well, it looks like anywhere that's bigger than 4. Okay, I'm also going to be rising on the graph. So from 4 to infinity. Okay, and that would be the answer to this problem here. Okay, now here's a question. Is the average rate of change positive or negative from x equals 0 to x equals 3? So one thing that we'll talk about when we get into chapter 2 is this formula is the same formula for the slope of a line. So if here's x equals 0, I'd be at the point 0, 3, it looks like. And here's the point when x is 3, I'd be at the point 3, 1. So if I draw a line between 0, 3 and 3, 1, are we going to be rising or falling? Well, I'll be falling, you know, from left to right. So the slope of that line is a negative number, some negative value there. Again, we'll talk about that, you know, in another section. But you're going to be falling as you look at this graph from left to right. So the average rate of change would be some negative number in that case. Okay, they're not asking for it, but is the average rate of change positive or negative from x equals 3 to x equals 5? Okay, well, if I draw a line going from x equals 3 to x equals 5, that'd be a positive slope. Okay, or I'd be rising on that part of the graph. So you'd have a positive number for the average rate of change. Okay. All right. We'll go ahead and stop right there. So the homework problems are on page 48 that I'd like you to look at there in section 1.3. And in the next video, we'll begin section 1.4.